Dear friends, today we'll be seeing what do you understand by branch instruction and what is the importance of branch instruction in computing. Branch instruction plays a very important role in case of computing because it allows to change the sequence of instruction execution. Now we know that the instructions have been placed in the form of sequence and when they are getting executed. Branch instruction allows of changing the execution in the way the instructions are getting executed. Target address is the absolute address given as the operand to the instruction. Target address is the address found into the link register. So what do you understand of branch instruction in a definition way? After executing the decision-making instruction, processor how has to follow one or two program sequences. Like if the programs have been interlinked and if the programs are into the pipelining of the execution, then branch instruction transfers the program control from one straight line sequence to another straight line sequence. So the instructions are being transferred in the form of branches, and these branches have the address bus, data bus, and control bus that are running into the branch instruction. In branch instruction, the new address is called as target address or branch address is located into PC, and the instruction is fetched from the new address what we have obtained. Now when you look at this diagram of the processor organization, it consists of the internal bus. To the internal bus, there are different branches being interconnected with each other. You have memory address register MAR, memory data register for data lines MDR, then you have ALU, you have the signals flowing in Y, multiplexers, signals like select, addition, subtraction, XOR means OR operation or XOR operation, and then the carry bit, and then you have the signal Z. Similarly, you have read and write on the other side. So all of these signals have been interconnected with each other in the form of branches, and they are connected to the control buses also. So instruction decoder and the control logic. This is being basically used and designed to control the different signals that are being interconnected with each other. And with the help of this internal bus processor, which acts as a mediator, the task or the branches are being assigned which needs to perform what task. So the sequence is being changed with the help of branch instruction. Now, why branch instruction is necessary importance, let us look into the register transfers. The data transfers between the register and common bus is known by a bus and a arrowheads. But in actual practice, each register has the input and output gating, and these gates are controlled by the corresponding control signals. The different control signals are R in and R out. Control signals for input and output of getting of register. Where when R in, that is, the data is getting in is equal to 1, the data available on the common data bus is loaded into the register Ri. When Ri out is equal to 1, the contents of the Ri are placed onto the common data bus. Now, when R out is equal to 1, the contents of Ri are placed in the common data bus. Similarly, the signals Ri, that is Ri in and Ri out, are commonly known as the input enable and output enable signals that help the signals of registers respectively. Now, with this diagram, you can understand how the register transfer takes place, where you have an internal process bus which is connected with the different types of multiplexers which are in the form of X, and they have been connected to the ALU, and you have R in signal and R out. Similarly, Y in and Y out signals. Now, when you are performing arithmetic or logical operation, the ALU is the combination circuit and has no internal storage. Now, ALU corresponds to the operands from mux, that is mux means multiplexer, and bus. The result is temporarily stored in the register Z, what we have seen in the previous diagram. What is the sequence of operations to add the contents of register 1 to those of contents of R2 and store the result in R3. So how will you perform this operation? You add the contents of register R1 with register R2 and store it in R3. How will you generate the control signals? The different sequence what we will be following for this example is R1 out, comma Yn. Now your signal is being stored in Y in. Thus R1 signal is being stored in Y. Then you will give the same instruction R2 out, R2 out and select Y. Now why you have selected Y? Because the contents of R1 are stored in Y. And then you will give the instruction add and store the addition of R1 out and R2 out in Zin. And Z out, comma R3 in. So the content of Z out is the input for register R3 in. Now fetching a word from memory. The processor loads address into a memory with the help of MAR, memory address register. At the same time, it issues read signal. When the requested data is received from memory, it is stored in the form of memory data register. So you have memory bus data lines and it is being connected with the internal bus. So how memory bus data lines are connected with internal process bus? It is with the help of memory data register, which acts as a mediator between the memory and the internal process bus. Connections of control signal for register MDR. Fetching a word from memory. Consider the instruction move R2, R1. Here R1 is into bracket, so it is an indirect mode. The processor waits until it receives an indication that the requested operation has been completed. Memory function completed, that is MFC. The action needed to execute the instruction is memory address register. So R1 indirectly is pointing towards memory address register. Activate the read control signal to perform read operation. If memory is slow, activate wait for memory function and complete WMFC, which is wait for function complete. So you need to wait till the function gets completed and you get the desired output. And again, then load the memory data register from the memory bus. So why you need to load the data from the memory bus? Because we are aware that the contents of the operand are getting stored in the form of data bus. So you need to load MDR from the memory bus. And again, R2 is indirectly linked with the MDR. So you will be loading the contents of MDR, that is memory data register, into the content of R2. Fetching a word from memory. The various control signals are necessary to activate to perform given action in each step. We have the different control signals. R1 out, MAR in, that is memory address register in read. Then you have WMFC, that is the second signal what we have seen in the previous slide. And then you have MDR out, which is directly getting stored with R2 in. Storing a word in memory. To write a word of data into memory location, processor has to load the address of the desired memory location into MAR. So first of all, you need to load the memory location where you need to store the data. Load the data to be written in memory data register and activate the write control signal. Consider the instruction move bracket R2, R1. So you will be moving the contents of R1 into R2. The action needs to be executed with the instructions are MAR, memory address register, indirectly referring to R2, memory data register, indirectly referring to R1. Activate the write signal, control signal to perform the operation. If the memory is slow, activate wait for memory function to get complete. That is WMFC. Wait for memory function to get complete if the memory function is slow. Now, how you're storing a word in memory. The various signal control signals which are necessary to activate to perform the actions in each step. The control signals are R2 out, comma MAR in memory address register in, R1 out, comma MDR, that is memory address register in, and then the write function. And then you have wait for memory function to get complete. So here the control signals are divided into two types. One is R2 and R1. First, memory address register is directly linked to R2. Now, R1 out is directly linked with memory data register, and it will be used for performing the write operation. As we are aware that for the operand, you need to specify whether it is a read operation or a write operation. And then at last you will wait for the memory function. Now, why waiting is necessary? Because you should be aware that if the processor speed is slow, then you require to wait for the memory function to get executed.